In this video, we're using technology to graph a complex polynomial and its derivatives so that we can see everything that calculus reveals about the curve. The function that we're graphing is f of x is equal to x to the fifth minus 5x to the fourth plus 5x cubed plus 10x squared minus 10x. I graphed this function using Desmos, a free online graphing calculator. Here's what f of x looks like. The first information that we need to find about this function is where it is increasing or decreasing. To find these intervals, we need to graph f prime of x, and I did this right here. To find where f of x is increasing and decreasing, we need to see where f prime of x is equal to 0. If we zoom in on this graph, we can see that it's equal to 0 at this point and this point. So let's write down that f prime is equal to 0 at x is equal to minus 0.87 and 0.43. If we look back up at the graph of f prime, you can see that the graph is positive to the left and to the right of these 2 points. That means that our function is going to be increasing. So let's write down that our function is increasing on the interval from minus infinity to minus 0.87 and to the right of 0.43, so that is 0.43, comma, infinity. Now let's look at the graph and notice that between the points where it's equal to 0, our graph lies below the x-axis, so it is negative. So we can say that our function is decreasing on the interval in between, and that is minus 0.87 to 0.43. And let's just make a note that this is f that is increasing and decreasing. Next, let's use our graphs to find where our function has local maximum and minimums. Let's now go back up and look up at our graph on the left, and that is f of x. You can see that at the point where our graph is changing from increasing to decreasing, right up here, we have a local max, and where it changes from decreasing to increasing, we have a local min. We know what the x values of those points are because those are the points where the derivative is equal to 0. So let's come down here and let's write that we have a local max at x is equal to minus 0.87, and we have a local min at x is equal to 0.43. Now what we have to do is find out the y value of that local max and min. To do this, what you have to do is you have to go to your graph of f of x and you have to zoom in. This top graph right here is zoomed in around our local max, and I'm going to zoom in further, and you can see that it is approximately 9.6. And then if we go down here to this graph is zoomed in around our local min, and you can see that that local min is about minus 2.2. So we can say that our local max is minus 0.87 and 9.6, and that our local min is going to be at 0.43, comma, minus 2.2. Let's now find where our function f of x is concave up, concave down, and where it has inflection points. To locate these intervals, we need to look at the graph of f double prime of x. I have that right up here. That's this graph right here. And we need to see where it equals 0. Let me go ahead and let's zoom in. And we can see that it equals 0 at this point, minus 0.37 for x. And then at this point, when x is 1.37, and then at this point, when x is equal to 2. To the left of minus 0.37, our graph is down here, and it is negative. And then in between 1.37 and 2, it's also negative. So that means in those regions, our function is going to be concave down because the second derivative is negative. Let's go down here and let's write this down. We'll say that f double prime is equal to 0 at x is equal to minus 0.37, 1.37, and 2. And then it's going to be concave down on the region from minus infinity to minus 0.37, and then in the region between 1.37 and 2. Now let's go back up to our graph of f double prime, and we can see that between minus 0.37 and 1.37, our graph is positive, and then it's also positive when x is greater than 2. So we can say that it's going to be concave up on the region from minus 0.37 to 1.37, and in the region to the right of 2, and that is 2 to infinity. Now, the only thing we have left to do is to find inflection points. Those are points where the concavity changes, and those are at these points right here. What we have to do now is we need to zoom in on our graph of f and find the y values at those 3 points. I did that, and I put this graph right here, and our 3 inflection points are right here, here, and here, and you can see their y values. We'll go ahead and let's write that down. Our inflection points are going to be minus 0.37 and 4.65. They are 1.37 and 5.14. And then our last one is 2.12. And that's it. You now know how to use graphs of f, f prime, f double prime, and how to zoom in on those graphs to describe everything about a curve.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.